In permutation, lot of importance is given for arrangement of things, whereas in combination, it is nothing but selection of things. In case there is only one way of returning, then the total number of ways will be 5 into 1. We have here a cricket team of 11 players is to be formed from 16 players. Hello everyone, I am Purnima, faculty in the Department of Commerce and Management, Vidhyaashram First Grade College, Temple of Excellence, MYSURU. I welcome you all to this session. In this session on commercial arithmetic, we will be having a discussion on permutations and combinations. Now, let us understand what is the meaning of the word permutation. Permutation refers to the different arrangement of things from a given lot taken one or more at a time, whereas combination refers to different sets or groups made out of a given lot without repeating an element, taking one or more of them at a time. Now, here we should understand that in permutation, lot of importance is given for arrangement of things, whereas in combination, it is nothing but selection of things. So, for example, in permutation, if you are given 1, 2, 3, 4, 5 numbers. So, we have to make an arrangement of numbers means I can write 5, 4, 3, 2, 1 or 1, 2, 3, 4, 5, 3, 1, 2, 5, 4, 2, 1, 3, 5, 6. So, in this way, I can make lot of arrangement of numbers and each arrangement has a different value. But whereas in combination, suppose I take combination, so I have to choose 3 beads or 8 beads from 10 beads. So 8 beads from 10 beads, out of 10 there are 5 black beads and 5 white beads. So if I have to choose 8 beads, so I may get 5 black and 3 white or 3 black, 5 white. So in this way. But here, whatever I take, that does not matter at all. So once I make the selection, the combination is over. But in case of permutation, we should understand that there is importance for each arrangement of the given element. So for each element, so you can see here, this number 5 is in the 10,000s place. Here 1 is there, here 3 is there, here 2 is there. So for each place or each arrangement has a value. But whereas in combination, we are not bothered about arrangement. We are bothered only about the selection of objects from a given lot. Then next, here we have an example here. So if I say combination, if I take 3 letters A, B, C, in combination, if I say one at a time, it will be A, B, C. But in permutation, it will be A, B, C again. But if I say 2 at a time, in combination, it will be A, B, B, C, A, C. So, I can either take A, B, A and B, B and C, C and A. But in permutation, we have A, B. This arrangement is separate. B.A is different. B.C, C.B, A.C, C.A, A. So, we can have different arrangements of the numbers. Now, if I take 3 at a time, A, B and C. See, you can see here A, B, C. This is one arrangement. A, C, B is a different arrangement. B, C, A, B, A, C, 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 B, C, B, A. So, each of them are different. So, it may be noticed that on the left above, every set has different combination, whereas on the right above, there are sets with different arrangements. So, here we have combination, here we have arrangements. So, this is arrangements and this is combination. Wherever possible of the same group. However, no element appears twice in any set, that is A, B, B, C, C, D, D. So, you don't have anywhere, but you have only a permutation and a combination. Now there is an example here. There are 5 routes for journey from station A to station B. In how many different ways a man can go from A to B, and if for returning any of the routes is taken, the same route is taken, the same route is not taken. So if you can see here, the man can go from A to B in 5 different ways, that is A to B. So he can go in one way, this way, third way, fourth way, fifth way. So there are 5 ways of going from A to B. But may take any one of the, see, 1, 2, 3, 4, 5 routes are there. So he can take any one of the 5 routes. That means there are 5 ways of returning also. If he has 5 ways of going to place B, then there will be 5 ways of returning from B. So there are totally 5 into 5, that is 25 ways. Then in case there is only one way of returning, then the total number of ways will be 5 into 1, that is 5. If there are 4 different ways of returning, then the total number of different ways will be 5 into 4, that is equal to 20. So we should understand that if there are 5 ways to go and 5 ways to come, so it will be a combination of 5 into 5, that is 25. And if there are 5 ways to go and only one way to come, so 5 into 1 equals 5. Then if there are 4 different ways, so 5 into 4 equals 20. Now, the next example, 3 persons go into a railway carriage where there are 8 seats. In how many ways can they seat themselves? So, there are 8 seats in a railway carriage. 1, 2, 3, 4, 5, 6, 7, 8. Now, how many persons go? 3 persons are entering the carriage. So, since there are 8 vacant seats, the first man can choose any of the 8 seats. So, there are 3 persons, A, B and C. Now, A can choose from any of the 8 seats. Suppose A sits here. Then, the number of seats left for B will be 7. So, B can choose any of the 7 seats. So, he will sit here. Then, C can choose from any of the 6 seats. So, C will say, I will sit here. So, the choices keep on reducing. So, the number of ways in which 3 persons can occupy the seat is 8 into 7 into 6. That is 336 ways. So, there are 336 ways of occupying the seats. So, 3 persons can occupy 8 seats in 336 ways. Next one. In permutations, we have different arrangement of certain number of objects, say taken r at a time from n different objects without repetition of any one of the given object in any one set more than once. Find out how many 4-letter words can be found out of the word logarithms. L-O-G-A-R-I-T-H-M-S. Logarithms. So, how many letters are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, we have 10 letters in the word logarithms. Out of this, we have to make 4-letter words. So, out of 10, I have to select 4-letter words. So, it will be equal to 10P4. So, this will be 10 into 9 into 8 into 7 into up to 2 into 1 divided by 10 minus 4 is 6. 6 into 5 into 4 into 3 into 2 into 1. So, this gets cancelled. So, I am 10 into 9 into 8 into 7. So, this will be 5040 ways. There are 5040 ways of arranging this 10-letter word into 4-letter words. Then, circular permutations. So, these are related with arrangement of objects as in the case of the sitting arrangement of members in a round table conference. So here the arrangement does not change unless the order changes. So if you can see here, in this A, B, C, D, E, this is a circular arrangement, and A, C, B, D, E. So you can see that both are similar. We cannot say that who is sitting at the head of the table or who is sitting in the side of the table, because it is a round table. So in case of circular permutations, how do you calculate? So in a circular arrangement, the relative position of the object depends on the position of the object placed first. It is only then the arrangement of the remaining objects is made. So in a circular arrangement, suppose I have to arrange A, B, C, D and E in this circular arrangement, then the first place, so first where I am placing the first object, so based on this, I will be placing the arrangement of different objects. Therefore, a circular arrangement of n objects will be in n-1 factorial ways and not n ways, when all the objects are considered for the purpose. Thus, the circular arrangement of 5 persons will be 4 factorial ways. So, if it is a 5 persons A, B, C, D and E. So, after this I make one selection, then I will be left with the rest of the 4 places. So, usually it will be n-1 factorial ways. So, I can do here A, B, C, D or E, or I can write here A, then B, C, D and E. So, anyway I can write. So, this I can do it in n-1 factorial ways. That is, if there are 5 persons in a circular arrangement, then the arrangement can be made in 4 factorial ways. That is 4 into 3 into 2 into 1. That is 24 ways. 24 ways we can make the arrangement. Now, in how many ways can 5 boys and 5 girls be seated around a table so that no 2 boys are adjacent? So, let the girls be seated first. They can sit in 4 factorial ways according to the rule indicated above. Now, since the places for the boys in between girls are fixed, the option is there for the boys to occupy the remaining 5 places. So, there are 5 factorial ways for the boys to fill up the 5 places in between 5 girls seated around a table already. Thus, the total number of ways in which both girls and boys can be seated such that no 2 boys are adjacent are 4 factorial into 5 factorial, that is 2880 ways. So, we should see that 5 boys and 5 girls are seated around a table so that no 2 boys are adjacent. So, there is a table here. So, we have to see that 5 boys and 5 girls are seated. So, we have 5 boys and 5 girls. First, I will make the girls sit. So, girl 1 here, girl 2, girl 3, girl 4, girl 5. Now, I have to make the boys sit here. So, 1, 2, 3, 4, 5. There are 5 options. So, remaining. So, the boys can sit in between. Now, since the places for boys are in between the girls, I'll make one boy 1, boy 2, boy 3, boy 4, boy 5. So, they can sit in 5 factorial ways. So, the total number of ways in which both boys and girls can be seated. So, that will be for girls, it will be 4 factorial into 5 factorial, that is 2880 ways. Now, what is factorial? 4 into 3 into 2 into 1 into 5 into 4 into 3 into 2 into 1, that is 2880 ways. Next, in how many different ways can examination papers be arranged in a line so that the best and the worst papers are never together? So we have 8 examination papers. 8 papers are there, and there is one best paper and one worst paper. So we have to see that this best and worst are not together. So the total number of arrangement that can be made out of 8 papers is 8 factorial. So since there are 8 papers, then I can arrange it in 8 factorial ways. Now let the best and the worst papers be taken together. These are taken as 1, and the remaining 6 can be arranged among themselves in 7 ways. So if I take this one best and one worst, if I consider them as 1, then 8 minus 1 will be 7, and the rest of the 6 papers can be arranged in 7 ways. So in each of these elements, the best and the worst papers can be arranged in 21 ways. So here, if you can see here, the total number of arrangements that can be made out of 8 papers is 8 factorial. Now let the best and the worst papers be taken together. These taken as 1, and the remaining 6 can be arranged among themselves in 7 ways. So we can arrange them in 7 ways. So in each of the 7 ways, the best and the worst papers can be arranged in 21 ways. Next, the total number of arrangements in which the best and the worst papers can come together are 7 factorial into 2 factorial, and the number of arrangements in which 2 particular papers are not taken together will be 8 factorial minus 2 into 7 factorial. That will be 40,320 minus 10,080. So that comes up to 30,240. So we can make a set 30,240 ways of there to arrange these 8 papers. Next, there are 5 boys and 3 girls. In how many ways can they stand in a row so that no 2 girls are together? Since no 2 girls are to be together, each girl must be placed between 2 boys. So place the boy thus. So we have this boy 1, boy 2, boy 3, boy 4, boy 5. So girl 1, 2, 3, 4, 5. So we have to see that the girls don't sit next to each other. So in order that no 2 of the girls be together, they can only be in places marked as X. So there are 6 such places, and so that 3 girls can be placed in 6P3 ways. So 3 girls can be placed in 6P3 ways. So out of 6 places, they can be placed in any of these 3. So there are 1, 2, 3, 4, 5, 6. So we have only 3 girls. So we have to select where the girls have to sit in between the boys. So we can calculate it in 6P ways, that is 6 factorial by 3 factorial ways. Further, the 5 boys can be seated among themselves in 5P5 ways, or the 5 factorial ways. Since for each way of placing girls, there are 5 factorial ways of placing the boys, the total number of arrangement will be, for the girls it will be 6P3, and for the boys it will be 5 factorial. So this will be equal to 6 factorial by 3 factorial into 5 factorial. That is, we can arrange them in 14,400 ways. Then, in how many ways can 3 boys and 5 girls be arranged in a row so that all the 3 boys are together? So, there are 3 boys and 5 girls. So, we should see that these 3 boys are together. So, in the previous problem, they were all different, but here they are all together. So, now what should we do? Consider the 3 boys as one unit. Now, there are 6 units, and they can be arranged themselves in 6 factorial ways. Now, what do? I have 5 girls plus 3 boys, I take it as 1. So, plus 1. So, that will be 6 units. So I can arrange it in 6p6 ways. So 3 boys can be arranged in 3 factorial ways. So it will be 6 factorial into 3 factorial. So this will be equal to 6 into 5 into 4 into 3 into 2 into 1 into 3 into 2 into 1. So that will be 4320 ways of arranging. Now combinations. Combinations are the groups which can be made by taking some or all of things at a time. So we can take a selection of things or we can take all of them. So there is nothing like that. So in a combination, order does not matter. It is simply the identity of items in the selection that matters. A change in any one item will constitute a new combination. So in permutation, we give lot of importance for arrangement, whereas in combination, there is lot of importance given. There is no importance for arrangement, but they will be giving importance only for selection. So for permutation, the formula is NPR equals n factorial by n minus r factorial. So for combination, it is NCR. So n factorial by n minus r factorial into r factorial. Now, in how many ways 4 white and 3 black balls be selected from a box containing 20 white and 15 black balls? So, there are 20 white and 15 black balls. Now, out of this, we have to make a selection of 4 white and 3 black. So, out of 20, I have to make a combination of 4, and out of 15, I have to make a combination of 3. So, what will be the combination? 20C4 into 15C3. So, this will be equal to 20 factorial by 20 minus 4 factorial into 4 factorial into 15 factorial by 15 minus 3 factorial into 3 factorial. So, when I simplify this, so it will be equal to 20 factorial 20 into 19 into 18 into 17 into 16 divided by 16 into 15 into 14 into 4 into 3 into 2 into 1. So, 16 factorial gets cancelled. So, 4 into 3 into 2 into 1. So, 4 5s are 20, 3 6s are 18, then 2 3s are 6. So, this will be equal to 19 into 3 into 15, 3 into 5 15, 15 into 19 into, again this will be equal to 15 into 14, 15 factorial by 12 factorial into 3 factorial. So, 12 factorial gets cancelled. So, this will be equal to 15 into 16 by 3 into 2. 3 5s are 2 8s are. So, 5 8s are 40. So, 40 into 15 into 19, I get the answer as So, we have so many ways of selecting the balls. So, out of 20 white, I have to select 4 white. So, it will be 20C4. Out of 15 black balls, I have to select 3 black balls. So, 15C3. So, 20C4 into 15C3. When I simplify this 20C4, I get 4845 and 15C3 is 455. So, together it comes up to 2204475. So, this is the answer. So, I can do it in 22,04,475 ways. Now, the next problem. A cricket team of 11 players is to be formed from 16 players including 4 bowlers and 2 wicket keepers. In how many different ways can a team be formed so that the team contains exactly 3 bowlers and 1 wicket keeper, at least 3 bowlers and at least 1 wicket keeper? So, we have here a cricket team of 11 players is to be formed from 16 players. So, they have asked, so they are, how many bowlers are there? 4. Wicket keepers, 2. Other players, we have 10. So, totally there are 16 players. So, totally 16 players. From this, we have to make a choice. In this first case, they say that exactly 3 bowlers and 1 wicket keeper. So, out of 4 bowlers, I am taking 3 bowlers, and out of 2 wicket keepers, I take 1 wicket keeper. So, how many players I have selected? 4. Now, how many remaining I have to select? 7. So, out of 4 plus 2, out of 16, I have taken 6. So, 10 will be remaining. 10 C 7. So, this will be equal to 4 into 2 into 10 C 7. So, that will be equal to 4C3 into 2C1 into 10C1, that is 4 into 2 into 120, that is 960 ways. Now, next they have asked at least 3 bowlers and at least 1 wicket keeper. So, out of 4 bowlers, they are telling at least 3 bowlers. So, 4C3 into 2C1 into 10C7. Again, it will come up to 960 ways. Now, suppose I take all the 4 bowlers. So, what will be the answer? 4C4. I will take both the wicket keepers. 2C2. Then, what will be the remaining? 10. Out of 10, I have to select 5. 10C5. This will be 4 into 2 into 10C5. 10C5 will be equal to 10 factorial by 5 factorial into 5 factorial. So, this will be equal to 10 into 9 into 8 into 7 into 6 into 5 into 4. So, again 5 into 4 into 3, 5 and 5 gets cancelled. So, again I am remaining with 2 into 1. So, 5 2s are 4 2s are 3 2s are 2 2. So, I will be left with 7 9s are 56, 56 into 4. So, this will be equal to So, they have asked exactly 3 bowlers and 1 wicket keeper. So, if you are taking 3 bowlers and 1 wicket keeper, so out of 4 you will select 3, 4C3 and 1 wicket keeper, that is 2C1. So, the remaining will be players. So, that is 10C7. So, 4 into 2 into 120, that comes up to 960 ways. Now, suppose the next question is at least 3 bowlers and at least 1 wicket keeper. So, 4C3 and I will take both the wicket keepers, 2C2. So, the remaining players will be 6. So, 10C6, that will be 4 into 1 into 2, 10, that is 840 ways. Now, I can also select 4 bowlers and 1 wicket keeper. So, 4C4 into 2C1 into 10C6, that will be 420 ways. Then, I will select both the bowlers, both the wicket keepers and rest of the players. So, 4C4, 2C2 to 10C5. So, this will come up to 252 ways. So, in this way, we can select a cricket team of 11 players comprising of 4 bowlers and 2 wicket keepers. So, with this, we come to the end of this session. Hope you have followed. Thank you.